Okay, so I have three good news. First of all, we are the last. So first good news. Second good news, no slides. This is going to be a panel. And third good news, you are all invited after this to the happy hour that is at the Marriott in the lobby, and we will all be present there if you want, if you have follow-up questions. So this is a heat reuse panel, and it's the result of bi-weekly calls that we have with the OCP about heat reuse, data center heat reuse. And so if you are interested, I definitely urge you to join our calls. They are sometimes spirited, but interesting, I hope. And we have 4 panelists here, and I'll let them introduce themselves. So I don't butcher your names.
You guys. Hi, my name is Jaime Comella. I'm from Cloud Heat Technologies. I actually co-chair the heat reuse workstream here in the OCP with Cosimo. And well, Cloud Heat Technologies is a known company for doing data centers based on liquid cooling, high-density data centers, and heat reuse concepts. So we have done it already in the different places in Europe. And well, hope you enjoy this panel.
Rob Bunger, Schneider Electric. I work in the CTO office of the Secure Power Division, which looks after the data center and edge segment.
And hello, everyone. I am Angela Taylor. I work at Intel in our Data Center Business Innovation Office. And over the last year and a half, I've had the pleasure of leading a team that is part of its responsibilities is looking at the impact of heat reuse in the data center, as well as the adoption of liquid cooling within that solution.
And I'm David Sickinger from the National Renewable Energy Lab. I work in our high-performance computing data center, and for the past decade, we've been implemented over 10 different liquid-cooled solutions, and we also utilize the heat reuse within our building that we're located, and talk about that in a little bit.
So we're going to have about 30-minute discussion, and then even a little less, and then we will actually like to open to questions. Angela, let me start with you. Why heat reuse and why now?
Sure, and I'm sure my panelists have a lot to contribute to this as well, so I'll kick us off. It's a great time for heat reuse. There are, maybe I'll just keep it to 3 particular points. One, we all heard multiple times today, and I'm sure if we're interested in this panel, we've read about the fact that data centers use a lot of power. And that energy that comes into the data centers is primarily released as heat, waste heat. And the majority of it is not being captured. So this has not gone unnoticed. Certainly as we look to how we can decarbonize our building stock, for instance, looking at data centers as a potential unconventional heat source is definitely of interest to the innovators who are doing it, as well as to regulatory bodies. So that would be my second point, which would be regulatory bodies. You're starting to see, certainly in the EU, it's been going on for quite some time, I would say at least 5-6 years at least. There's been the Green Data Center and Green Cloud policy where they are looking at encouraging through multiple instruments the heat reuse. So whether that's investments, subsidies, as well as rewriting policies that currently exist to include the discovery of heat reuse. And while the EU is certainly way out front, and I'm sure the examples today will be centered a lot in the EU, it's also starting to, which is exciting for us, it's also starting to proliferate to other geos. So in the US, there's been a couple of states just this year who've started to dip their toe into this area. I will say that my state of Washington is one where they have implemented just this year, a program, it's an industrial symbiosis program. And while it is not directly targeted at data centers certainly can benefit from the tax incentives and all of the support that goes around it through matchmaking, through technical support that goes on by taking one waste stream and feeding it into a target recipient. Also saw in California recently with their energy codes. It didn't quite pass this year, but I expect it'll probably come back around knowing California. And finally, I would say, just as a snapshot, Beijing. China is also making a lot of headway in this area, and Beijing in May put forward in their province a policy that is making new data centers take a look at how they can insert the waste heat from data centers into their district heating as they look to decarbonize that area. So, you know, a combination of, there's a lot there, it's very valuable, and I could go on about the value, I'm sure we will hear, combined with the incentives that you need, the policy and the investments.
Yeah, so, and we actually heard before today about Wyoming, white box, where actually even financially it makes sense if you have a good case. So, and it's funny that you mentioned supply and demand, because one of the things that we are trying to push with the OCP is a kind of the Tinder of heat reuse, to combine offering and use. So now that we understand why it makes sense to actually plan for heat reuse, we need to measure, right? What heat, this movement of heat, and you have been working on this for a while, Rob, right?
Right. And, you know, so as we talk about metrics, you know, I think you've heard quite a bit in the last few years that it's not all about PUE. But the organization that started PUE actually, many years ago, came up with the metric to capture heat reuse. So I think ERE, ERF, which many of you have heard about. So as we look at the sustainability of the data center, and we've kind of looked at it in 5 main categories, which is you know, energy, carbon, water, waste, and land and biodiversity. You know, on the energy side, you know, the energy reuse captures, you know, the amount of, obviously, energy and heat you can get on the way out. You know, that is actually, it's not just a green grid thing, it's now an ISO IEC standard, which can be referenced. It's also to note that as the EU DCA and I think the carbon neutral initiative also calls out as a main category heat reuse. And as already stated, you know, there's legislation coming down the road that's going to look to try to take advantage of that heat there. So the great thing is you know, we have the metrics in place to go measure what we're doing and show improvements.
Now we need the wheel to do that. And speaking about wheels, so we have 2 examples here, Enrail in the US and Cloud and Heat in Europe, that they have been doing heat reuse for quite a while. So I don't know who wants to start. I'll let you decide.
Sure. Well, since I'm sitting next to you, I'll go ahead and start. So at Enrail, you know, we were sort of fortunate. We had an energy champion at the executive level. So when they were starting to consider the design for our HPC data center, high performance computing data center, sort of the 2007, 2008 timeframe, they sort of saw that in the HPC world, at least in terms of the rising rack power densities, that liquid cooling was on the horizon. And so they made a commitment to direct liquid cooling, so we put in the hydronic infrastructure in place. With that sort of comes sort of the different increased supply temperatures. You know, our facility is sort of main facility loop is 20 degrees Celsius. We're looking for 35 Celsius back in terms of return temperature. The building was designed sort of in a holistic way to make use of the low-grade heat in terms of the office space and the corresponding lab space, which requires high ventilation. And so you could sort of preheat that air, makeup air with the heat coming off of our data center. So they had that vision, and so when we opened up in 2013 timeframe, you know, it was sort of the first return to liquid cooling in the HPC environment. Rack power densities at that time were sort of 40 kW per rack. Our current flagship system's operating at about 70 kW. And when we deploy our next HPC system early next year, we're starting to see rack power densities of 200 kW. it's kind of getting a little hard to call them a rack anymore because now they're sort of a big cabinet that weigh more than a heavy-duty truck. But that's sort of the world that we've been operating in. So, with that, right below our data center is the mechanical room, and in that room, we have a set of heat exchangers that we can kind of transfer that heat to our building system. Because we just use heat exchangers for radiant heating, and then also for loops that sort of preheat the makeup air on the lab side. Our ERW, or ERE, thank you. Too many acronyms. ERE is, we've seen sort of on an annualized basis of 0.9. So that's about 11% of the energy over the course of a year that we're able to kind of reuse without boosting it through the use of heat pumps. If some lessons learned is, we have only the single facility loop that is dedicated just to our data center. If we could kind of do things over again, we'd probably put in 2 loops or think about how we do that, because we still have an air-cooled component, and that air cooling plus the liquid cooling sort of reduces our overall temperature for our main facility loop and what we can do with it. So, or the other option is the future systems. Hopefully the supply temperatures and return temperatures both increase, in which case we see a lot more benefit from energy recovery, which also does save us on water, because water is important in our area as well. But if we could get up to sort of 40C, 50C, we'd be doing a lot better. And so
and more. Actually, we started in a very small setup, rather edge computing, we say, in private houses, in the cellars of private houses. Actually, our founder is there, Jens. Hi. Sorry, visionary. And at that time, we started with distributed computing in the cellars of houses, and the idea was actually to heat those houses and to deliver domestic hot water. So we needed to reach very high temperatures. We needed to kill Legionella. This needed to be actually a secure water for domestic hot water. And that's why for us, the hotter the better, yeah? The hotter the better. And we pushed actually the boundaries of the chips. I mean, we are a bit sad to see that some chips temperatures are going down, and we hope that the design of future chips will keep high temperatures, because the hotter, the better. Again, 3 times I have said that. You create at the end an asset. At the end, the water, the hot water, you have after going through the computers, you can resell it. I mean, it's a much higher value if you have it at 60 degrees Celsius than 35 degrees Celsius. So we started there 11 years ago. Then we go to a data center in a skyscraper. We also have done containerized data centers with very fabulous numbers. This morning, my colleague Leonie, who's there, I think, presented a containerized data center, very high density containerized data center with 2.16 megawatts IT power in a 40-foot container. And actually, 95% of that can be captured, more or less, 95% of that. And this can be connected to a district heating network. So the potential of the heat reuse is not there. I mean, we are doing that already. I mean, so just to close a bit the circle, yeah, because you started asking why, and I think we left a topic, and is the actual energy crisis. Yeah, I mean, climate crisis, we are there since a lot of years. Energy crisis is something very recent. And we are seeing, in particular in Europe, a lot of interest of really reusing every kilowatt. If you think about each watt that comes into the data center in an electric form, goes in form of heat, and we are actually just sending this to the air.
It, yeah.
10 megawatts data center at 80% utilization is equivalent to 40,000 Californian households heating. 14,000. It's equivalent to $3.5 million per year of cost that you could avoid. It's equivalent to 12,500 tons of CO2 equivalent per year. So these numbers are, well, I don't know if you can envision how big are these numbers, but they are very positive. I don't think we have to push for a change.
Yeah. And something that was clear, I don't know, you want to say something? Okay. Something that was clear during our calls. So we have been working in this heat reuse group Jaime is co-lead of the heat reuse group. So for what, 8, 9 months. Yeah.
Yeah.
And we had 10, 12 presenters presenting experiences of heat reuse, mainly from Europe. Of course, we're lucky to have Unreal actually in the US, but it's hard to find a heat reuse case in the US. But one thing that was clear is that there's not one solution that fits all. So every situation, every size, every climate, every position, if it's urban, is rural. So in these, what is the biggest challenge that the four of you see in actually implementing on a large scale, actually, heat reuse in the US? Because Europe is already ahead. It's running circle around the US about this for the reasons that probably you mentioned before.
Maybe I'll kick it off. So a couple of things that pop to mind. One of them is the upfront cost. So certainly it's not free to do it. When you're building the data centers, you need to be thinking about heat reuse at that point in time. So when you think about retrofitting a data center, the ROI on that may not pencil out. I'm not saying in all cases it won't, but you certainly have to take a much more critical eye. So once you're able to intercept it and present all of the fabulous reasons why this makes sense for the environment and financially, and not only that, but one thing you didn't mention, Jaime, that I know is cropping up in the EU is a lot of pushback on the data center providers from the communities in which they're being built. Because they are, it's pretty big. Just Google Ireland and data centers and you'll see it. I mean, moratoriums, because they're concerned about the amount of energy that the data centers are consuming. So there's that piece of it. And I think the next piece in the US is that we don't have a really robust district heating system like they do in Europe. So that's definitely an issue. That doesn't mean that there aren't opportunities. There actually are a lot of opportunities. You just have to be much more creative, and we need a bit more
Let me build on that. Let me build on that, though, because the imagination immediately goes to the 100 megawatt hyperscale giant in the desert heat reuse opportunity. That is challenging. While if we start with a 1-2 megawatt maybe edge, and at that point you have hospitals, you have university campuses, you have company campuses where, like Unreal, for instance, it's a campus that, so you would have these opportunities if we only thought about this, right? Yeah.
Well, just to build on that, yeah, I mean, at Unreal, we did have the campus, but, we first thought about using the heat within the building we're located first. That makes the most sense to start off with. And then we are looking at, once we kind of increase, next year we'll be going from 1.5 megawatts to up to 4 megawatts. We can start to think about exporting to our local campus. And we're already sort of tied in with that, being on a campus, a small campus already set up for that. But that does sort of bring up the edge possibility that, and as some of the different case studies we've heard about in the OCP heat reuse group, is finding that pairing to where you can utilize the heat is key, because long distances of pipes and networks is going to be cost prohibitive. But if you can kind of make that connection and work that through, or industrial, we've been hearing about a variety of industrial use cases, and pairing that up with like an edge type facility makes a lot of sense. So.
And I'll add, I do have hope in the innovation that communities like this will bring. I mean, very early in my data center career, I remember, the whole absorption chiller. So, taking the heat, running the absorption chiller, which is used to cool the data center, right? And that ended up in the pencil out, I think, category in the early days. But people were thinking about it, and I was, I don't want to say early in my career, but it was a long time ago. So, I think as we start to look at computing at the edge, which you've alluded to, there's going to be, opportunities that you guys are already executing on that I think we're going to find a lot of new opportunities. And again, it's not just export potentially for external use, but there might be some innovations where you can kind of bring it back to the data center and find some way to use that.
Proactivity, I would say, that's very important, to start before the project starts, looking for connections, start going to utilities, look, that plot seems interesting, I have a lot of power, I have fiber, but it's in the middle of nowhere. I have that other plot, maybe the connectivity is not so good, but there is a brewery there. I can give heat to this brewery, or an industrial laundry, or a hospital, or a swimming pool, or even, I don't know, a greenhouse that needs cooling. So my colleague presented this morning as well, using, of course, absorption. But actually, you can use heating for cooling, or for desalination of water, for water treatment. So there are a lot of usages, and in the industry, the textile industry, in the metallurgy industry, chemical industry. So actually, it's proactivity. Start looking for that, and that's the most difficult thing, and that's actually what we try to evangelize in our OCP group.
In our calls, yeah. So let me address the elephant in the room here, let's say. We haven't talked about that, but we take for granted that when we talk about heat reuse, we talk about it's linked to liquid cooling, right? Some sort of liquid cooling. We don't care about what technology, but is it possible to imagine a heat reuse for actually an air-cooled server?
I mean, there is the one case up in sort of Seattle area where they are doing that. And, you know, some of that is utilizing heat pumps to boost the temperature to working conditions. And then I think some of that does come back into the sort of the policy mix of what are some of the other drivers if the temperature that you're working with, you know, isn't quite as hot as you could get with potentially with liquid cooling. And then some of it is not always about the technology. It's actually, we've heard enough stories too in OCP working group that it's more about making that pairing of, you know, how do you, if you have two or more entities, how do you do that transition? And that can be a bigger challenge than the actual technology if it's just heat exchangers and a heat pump if you need to boost it to make that case, and what do you do there? So, but what is exciting though is, you know, we've been doing it since 2013 timeframe, kind of haven't seen much activity, but the last 2 years, we've really seen an uptake in interest in this. And I think more and more sort of thinking about that in the early stages, which I think is key. And if nothing else, at least put in taps, you know, for future to allow you that possibility, because that's a cheap way to do it. So, or at least to allow you options in the future.
I just wanted to, you know, you're talking about temperatures and things like that, and for any of you that have been in any of the liquid cooling groups or discussions in general, right, we talk about, you know, case temperatures, and the hottest chips out there might need colder case chips, and everybody's like, hey, what about heat reuse? What are we going to do? So what I find easy, so that has been the driver, obviously, for, you know, all this talk about liquid cooling and going to liquid cooling, but, you know, once we hit the tipping point where it's easy to do liquid cooling on anything, and we talk about more traditional regular servers, right? I think that you guys are doing, and then you can actually use really those warmer temperatures. So I'm really excited about the proliferative, the tipping point of the hot chips making liquid cooling make sense for almost any server.
Yeah.
And then I think the regulation push to do heat reuse will also push it in that direction.
So maybe I'll just comment on that a little bit. Since he talked about temperature. No, it's
Gently.
He was kind. No. So there's a couple things I want to say about that. One is that was an area we looked at quite extensively, was how could you do heat reuse at what level with what TDP for a particular compute component. And what we found was that at a 60% utilization, which is about normal in the cloud world, you could still get 60 C outlet temperature if you could control for that 100% of the time at 550 TDP. So that's high. I mean, that's a higher end chip. Accelerators are much higher, in which case, if you're running them all the time, your chances of doing heat reuse without a heat pump or doing heat reuse in general is going to be pretty low. But those typically are smaller use cases in a data center, unless it's an HPC, of course. But I think those are the extreme cases, and the opportunity and the innovation. Honestly, the technology's out there, the telemetry's out there to be able to do cooling control to get yourself a higher temperature.
Yeah. So I think that's a great point, because you see all the standards that come out from ASHRAE and all this other stuff. You say, oh, you got to go lower and lower, and so everybody's like, oh, great, I'm just going to have to permanently set it for that. But you won't, right? If you're running at 60%, jack it up, lower it if you need to.
Well, I was just going to add, as listening to that discussion, is just sort of reminded too, is, the flexibility and sort of what we heard this morning from Wyoming case about, having the flexibility to deploy all of the three main categories of liquid cooling and different supply temperatures. And so I think there are strategies that you can kind of do, and as people, I think, share their success stories or lessons learned along the way, there are ways to address that, either through multiple loops or control strategies so that you can find that right combination for whatever your heat host needs are that you've matched up with. So.
Yeah, and then the other thing that we notice is that the disconnect between people that have been doing these and people that are thinking about these is that the people that are thinking about these, they want the perfect solution. They want the 100 megawatt data center heat reused 100% of the time, constantly, with no hiccups. While we are not doing anything right now. So if we were to recover even a seasonal heat reuse like district heating or whenever, like greenhouses, as we heard this, earlier today, it's not perfect, but it's better than nothing. Do you think that this kind of aiming for the highest possible target is kind of slowing the adoption?
Yeah, probably yes. Actually, we're now seeing in Europe some colo providers, huge data centers, only giving 10% of the waste heat. And this is a start. At the end, we see our map, how it's getting populated with dots. Yeah. And this encourages the others to do it. At the end, if, I don't know, brand A, I don't want to say brand A sees brand B, so the competitor doing heat reuse, they will want to do that.
So he's referring, we actually published a map, the OCP published a map of all the heat reuse projects that we could find. And if you want to see the map, just ask us after the call. We can. And if you have a heat reuse project that is not in the map and you want to be in the map, please. But so from your point of view, what you hear about heat reuse, are you looking for? Do you hear this perfect Prince Charming situation, or we have to settle as my wife did with me?
I won't comment on that, but that's actually not come up in the conversations I've had. David's probably had more of these conversations, or maybe my colleagues here, but I would just say that the renewable energy sources currently are not 100%, right? Yeah. So I think we all need to recognize that, is that you can get a steady stream most of the time, and your efficiency can be quite high with heat reuse in the data center, whereas solar and wind has very low efficiencies. So just something to think about.
And just wanted to clarify, from our design that was implemented is, we feel lower CapEx and lower OpEx in terms of implementing that. So even though at the moment we're only recovering maybe 12% over the course of a year, if the temperatures do increase, we'll be in better shape, but it didn't cost us anything to do that. It was just some upfront design and thought that went into it. So I think you can find that right balance of, the sort of the techno-economic studies and making that case and to at least give you those options. And so, yeah, it doesn't have to be the perfect scenario. I think, we've heard about one case, Lumi Data Center,
yeah.
And they were very impressive where I think their PUE was, around 1.1, but they added heat pumps, so they did account for that, and they went up to 1.25 or was it 1 point?
Yeah. And they are in order,
1.2, but their ERE is incredible.
Yeah,
I mean,
but they
recover 100% of the heat.
they are in northern Finland, so.
So perfect location, but that's one scenario of the perfect example. That's going to be hard to replicate, but again, I don't think you need to necessarily go there. So.
Last point. So about 10-ish years ago, energy sourcing and renewable was the talk of the town. Everybody was trying to, let's say, it started the conversation for data centers to use renewable energy as a source. Now it seems that the water consumption is the talk of the town. Everybody's concerned about water consumption. Do you think that the next step is going to be heat reuse?
Well, since we're just talking about water, though, too, I mean, keep in mind, heat reuse, you're not rejecting heat to atmosphere, so
Yeah, exactly.
you're saving water right there, too. And then I'll let others comment on.
I agree. I think the path on the electrical side from a renewables and working with the grid is clear. Work to do, but it's pretty clear where we go. The need to reduce water, I think is clear, and there's technology to do that. So yes, I think the energy reuse is fuzzier. The path, there's a few paths, but I think over the next couple of years, it's going to get much clearer.
All right, so if we open to two questions now, if you have any question for our panel, not for me because I have no answers, but. Okay, he was faster.
My name is Shankar from Danfoss. Just a quick comment. I don't know if there is any merit to that, but the metric currently we use is ERE for energy reuse, right? That's a new metric. People are not used too much. But how about redefining PUE as changing the numerator to deduct whatever heat reuse you are using? That way, people are more used to PUE. Now they can target for a lower PUE.
As I said, I have no answer, so.
True. I guess we sort of, at least NREL, we sort of like the family of PUE metrics. So we start off with PUE that people are familiar with. Next iteration would be sort of total usage effectiveness. I think that's where you really draw out your fan energy, your pump energy from your IT load. ERE is, when we're talking about that and sharing that, it's the only difference between that and PUE is you get to subtract out how much energy you are able to reuse. And so you can have numbers lower than 1. Perfect ERE number would be 0. Whereas PUE is sort of limited to just being 1 as a perfect number. But then also within the family of PUE metrics, sort of say water usage effectiveness, and then also CUE, carbon usage effectiveness. Yeah, not everybody's as familiar with those, and so it is about messaging and who you're targeting and whose support you're trying to get to how you deal with some of those.
Yeah. Having a PUE less than 1 is a heated discussions that definitely have happened before. Right?
And I think that's what led to the metric ERE, right?
Yeah. No, it's ERE. You can't have a PUE less than 1. So, it's a good point. It's definitely been discussed. But because there's more, there's going to be carbon, all this other stuff we have to track. So I think having this family of metrics is going to be the way people get used to getting over just PUE.
Okay, yes, I want to be provocative. So you've talked about, heat reuse of, say, 11%. In the EU, for example, supposing we start bringing this legislation along, we've talked about free cooling. It's not really free cooling. We're just venting to atmosphere. So there's an anthropogenic heat flux. So what happens if we start charging for release of heat to the environment? Well, your bottom line may be different then. So what do you do in that situation? Yeah, if it comes along, it will come along, I think, in Europe.
I'll let them reply. In the US, we are far from that. But I don't know what you think.
What's the question exactly?
What if we charged for the discharge of
Well,
heat.
let me give you an
into the
example. I mean, if you use water in Europe,
Carbon tax,
you're charged for venting to drain. You're metered on your water consumption, you're metered on what goes to drain. If you're metered on your electricity consumption, you should be metered on what you vent to atmosphere.
It's a sort of a carbon tax we were.
Totally agree. I mean, so we will see all the data centers doing heat reuse projects. I mean, of course, if there is a monetary upside down, then of course there will be some investments in that. Yeah, and we saw.
Yeah, there's another.
Okay, sorry.
Gentleman there.
Yeah, hi, my name is Phil Raffles. I'm with Nova Power International in Montreal. We're developing systems to produce power from waste heat from liquid-cooled data centers. And I mean, I think heat reuse is fantastic, and if you can use 12% of the heat directly, that's great. But that other 88%, if we can give you back 8% as electricity, then it seems to me you do have a PUE below 1 because you're net using more power than you're taking.
What temperatures do you need, though?
55, 60.
We should talk, I guess.
We should.
Yeah. Well, maybe I'll just comment on that real quickly. And yeah, I would love to talk at happy hour. We did look at that as an option. So distributed heat, the efficiency of distributed heat is quite high, right? 80%, something like that. So if you can transfer that quite easily. But converting it back into electricity is certainly a use case, but the efficiency was pretty low, like 7% at the high end for high heat. That was 70 C or above. So if you guys have higher, then really excited at lower temperatures to see this come to be, because that right there is the golden goose.
It's not a lot higher, but the capital costs are low, so 89% is.
But again, it's the same situation. Is it perfect?
Yeah.
No, but it's a first step, right?
It's great.
It's using a garbage otherwise.
Yeah. No, I'm super excited to hear that. Thank you for sharing.
There's another.
So if you look at the life cycle of servers, the first couple of years they're used in data centers. But then what about the rest of the life cycle of those components? If we would take those CPUs and GPUs and put them in appliances at people's homes, I think there's an opportunity there to do more reuse of the same resources. Is that something that you could see happening? Is it a topic we could pick up in our heat reuse group, even though it's not, not strictly speaking data center, but I think it's OCP, could be OCP scope.
That's what you started doing, right? You just
actually, yes.
Southern Heat. Yeah.
We're doing that, yeah, actually in private houses, yeah, directly where it was needed. Yeah, I mean this was actually the core of the business at that time. So the first rack was in the cellar of the other founder who's not here, and we were selling cloud services based on that to third companies. I mean, we weren't selling cloud services to the owner of that house, but yeah, exactly. And we see that also Carnot. I don't know if Clément is here. Yeah, here is there. They're doing also the same. I mean, yeah.
And does the chair think that could be something we can pick up in the scope of the heat reuse group?
Yeah, I mean, yeah, absolutely. So I think our time is up. If you don't have more questions, thank you very much, and happy hour.